So we are here to talk about PCF in NSX. We would dive a little bit into NSX-V versus NSX-T, how it changes the game for PCF. What would be the changes you can expect when you start looking at NSX-T? And are there tips and techniques that you can use to automate while dealing with NSX-V? So how many of you actually use NSX? So how many of you know about NSX? Okay. So just for the benefit of others, NSX is a SDN solution from VMware that lets you create networks using software rather than doing a hardwired network and stuff. You don't go around creating switches or routers, but NSX lets you do things using the software-defined networking. Okay, I need to hit play. Okay, so safe harbor statement. I'm going to talk about product that's kind of coming out pretty soon, either end of December or beginning of January, for both PCF and VMware's NSX-T product. So this would be the agenda. We'll be talking about PCF with NSX-V. What are the challenges with it? What is the normal deployment model? What we recommend to customers to use? What are the things that you can use in order to alleviate the pain associated with the NSX-V creation and maintenance? And then we will dive in a little bit into NSX-V versus NSX-T, and a lot more into NSX-T. And we will have a little bit of demo for both. Okay, any questions? Okay, so how many of you have seen this reference architecture for NSX-V? So this topology was kind of created by the professional services team from Pivotal that helps the customer lay out the different components in a right network logical switches so things can work together. And it uses something called a cookie cutter approach, wherein you can say infra logical switch would be meant for BOSH, director, and ops manager on a 192.168.10. something. And next, there might be a ERT logical switch that basically would host the whole ERT, and so on. So you would actually have different logical switches for different types of deployments. So these are ultimately deployments. Ops manager and BOSH director are VMs directly running, while ERT and anything else that comes afterwards would be deployments through BOSH. And this is what you would normally configure on Ops Manager to say, okay, I need like 5 networks or 3 networks or just one flat network. So these are networks that would be created on top of an NSX-V Edge. So there is essentially one NSX Edge. I don't know why I'm not able to see it. Okay, so there is an NSX-V Edge that basically creates a boundary on which all these things would be running. It acts as a gateway for any inbound and outbound traffic. And behind it are all the different logical switches for the different networks. And then you would either deploy manually or you might use some tooling to say, okay, let's bring up Ops Manager and BOSH Director on this network. Let's configure the Ops Manager with all these different networks with the logical switch names and stuff. And then you start deploying the ERT and then the MySQL or the Rabbit or whatever services. Then you might also have isolation segments. So using an edge, you would be able to kind of carve up the logical switches and then start creating a one full foundation. That way you can actually have multiple edges, each kind of using the same logical switch subnets. So, and it's also encapsulated. There would be a NAT communication going out. So that way, like each edge would encapsulate whatever is the deployment within it without it bothering the next one. So that way you can basically have like a prod foundation, a dev foundation, a pre-prod, or a SIT or whatever, right? So how many people follow this? Okay. Or how many people just don't use anything? Or just custom manual stuff? Okay. So this is NSX-V. How many of you have actually configured NSX-V? I can tell you, or you guys can tell me, or you folks can tell me. Like how many clicks would be there? Okay, let me go create this edge, then the logical switch, then come back and set this uplink IPs. Oh, did I calculate all the IPs? Oh no, I need to go and shift things around. And then go back, look at the allocations. Oh, I need to configure the NAT stuff. I need to configure the firewall stuff. And how many clicks would that be? It's like each edge would be like hundreds of clicks. And then invariably, you are not sure whether it works or not till you start deploying things. And then I'm like, okay, there is no uplink. Oh, what's happening? Okay, go figure it out the hard way. It's quite time consuming, it's manual, it's tedious. And you are actually in charge of deploying multiple of these. It's like, okay, how many times can I keep doing this? So based on the feedback from VMware and the field, I kind of created a tool called NSX Edge Gen that would help you automate the NSX Edge creation that follows the reference model, reference architecture topology we just saw. It's also extensible, wherein you can say like, okay, I don't want everything to keep going through the edge. I want a DLR, a distributed logical router. So it has the option to say, okay, enable a DLR with OSPF ring around the deployments. So you avoid going back to the edge and coming back like a hairpin bend. With the DLR, you can go more than 10 logical switches. So if you are thinking of isolation zones, okay, you might be able to do like probably 4 or 5. With all the other networks, you are hitting the 10 limit, number of 10 for a normal edge. So with a DLR, you can go to thousands. And the whole thing is, it's automated. You can get consistent results. You don't have to worry and figure out like, okay, did I configure the firewall? Did I configure the NAT? Did I configure the uplinks? Or I need to change the number of routers. Did I assign the right IPs to the pool? So all of this is taken care for you. And you can create an NSX Edge in a minute. So it's on a public repo. You folks can check it out. And there is also a NSX CA Pipeline. What it does is one-click full install, creation, and deployment of the edge with the ERT, with the Ops Manager, with all your services. So essentially, it uses the tools inside a Concourse pipeline to create the edge with the specifications you have suggested. And then it feeds off from there and says, okay, there is this logical switch. And these are the pools, these are the load balancer names, these are the IPs, these are the uplink IPs. So let me start wiring them together and deploy the whole thing for you instead of you coming in and saying, okay, let me go back to NSX Edge, look at what is the name of the logical switch, what is the name of the pool, what is the name of the, what is the uplink IP. So you don't have to do that manual data transfer. It's taken care for you. And also it has support for the security group binding. So you can say like, I want to leverage Bosch security group and associate that with the load balancer pool. So now Go routers, you might start off with 2. You might come with like a later more number of Go routers. As you scale things up, it would be just associated with the security group, and so you don't have to go in and configure the pool with the static member IP list. So it's quite dynamic, and it lets you go on. So both of them are in a, so this would be a pipeline. It basically, I don't know whether people can zoom in, but so it basically kind of creates an edge followed by laying out Ops Manager and installing the Bosch director and everything all the way. And I do have a blog post you can actually read in more detail. So let me quickly run a demo. Are people interested in demos or they hate them? Demos to fail. So you can look at the number of edges. Currently it's like edge 74, I think is the last one. Edge 74 is the last one that was created. So I'm going to just run this command. Let me quickly show you what it does. It basically says initialize with some configuration name. And it already has some kind of other credentials which I'm not showing here with the vCenters or the NSX Manager credentials. And then you start creating like, okay, what needs to be, whether you want a DLR to be enabled, or what distributor port group, if it is DLR enabled, now you can also say Bosch NSX enabled. I don't know how many of you have used the Bosch NSX feature to say like, okay, I want to enable for NSX integration, NSXV. So that basically lets you say like, when I'm creating a VM on vSphere, I want to associate a security group with it so that I can manage things from NSX. And then you can also configure like what needs to be your domain name, so it can generate self-signed certs. Probably you can modify it to use whatever certs you have. So you can also come up and say, I want to have like a, how many number of MySQL ART instances or routers or no, well, almost everything can be configurable through command lines. So this was built so the pipeline can actually provide these parameters to you. So I'm going to directly do a build because in the interest of time. So right now, there is nothing here, just till 74. So I'm going to, it will be kind of emitting the data about the credentials and other information that you provide in the command lines. So this basically would kind of tell you like what would be the load balancer name, what would be the pool name that you to be building for you. So that way you can look up or look later. So it basically says go router with SSL or no SSL. Sorry for the line prep. So these would be the static IPs. Like you can basically say this is a subnet and I want to start off from here as an offset and then say like 3 instances or 2 instances. So it kind of does the calculation and lays it out for you. You don't have to do this like, okay, with this CIDR, what is the next IP, what is the thing. So it basically lays things out for you. So it finished the domain, the credit creation, the source generation. So it takes care of all the SSL cert association for the NSX Edge too. And the code is written in Python, so you don't have to go and worry about Golang or recompiling things. Was this under a minute? So this is the edge that got created. You have got the interfaces. So these would be all the uplinks. Some of them would be internal, not exactly external. So these would be the different logical switches that gets created. You can basically right now, like my firewall is not too restrictive. It basically says components within the deployment can talk to each other, can talk out, but you can restrict it. So there is an export functionality too, so you can export the firewall rules that are on an existing edge and then feed them into this one. So it basically has the firewall rules, it has a NAT, and it has we can look at routing if it is OS DLR enabled, so it is still kind of loading. And so in virtual servers, you can basically see the virtual servers are already created with their pools, with their IP addresses. So those would be the uplink things that you want to expose for a Go router or a TCP router or a SSH. So all of these is laid out, and you all have the pools and the profiles and the monitoring, everything is set up. And now the only thing is to kind of start the pipeline. The pipeline basically would do this along with laying out the bits and installing Ops Manager and Bosch director and everything. So any questions on the NSXV part? So this is mostly around the NSXV tooling. Is it useful, not useful, don't care? So yeah, you can basically extend it to whatever the firewall rules you want to apply or you want to change the templating. So here's the pipeline, so you can configure the parameters. And Concourse, how many of you have used Concourse? Okay, okay, good. Thank you. So you can configure the properties and essentially it would get translated into tasks on Concourse. And this is supported for 1.11. I haven't built one for 2.0. So these would be the parameters you might actually configure. Okay, let's go back to the presentation. NSXV, okay? Yeah. Okay, so coming to the comparison matrix for NSXV versus NSX-T. NSXV is meant for meant for VMs. NSX-T is meant for containers. Is it clear? NSX-T is the new generation transformers version of their SDN software from VMware. It is still called NSX, but the NSX-T is totally new generation meant for containers. And it can support all the Docker, the Kubernetes, and PCF. And PCF is getting rebranded as Pivotal Application Service, so you might see PAS reference over here. In terms of encapsulation, NSX-V uses the standard VLAN, while NSX-T uses a little modification called GNU. In terms of form factor, NSX-V is meant to be deployed on VMs, while NSX-T can be on bare metal too. In terms of hypervisor, NSX-V is ESXi only, while the other one is also KVM. So NSX-T has more options, more flexibility, more deployments. In terms of vCenter integration, NSX-V is tightly integrated, while NSX-T can be standalone. And in the future, it can be also on public clouds like, I don't control the decision, but it can be on public clouds, so it's not like only private. And in NSX-V, user creates an edge instance, which encapsulates the whole SDN solution. While on NSX-T, people don't create edges. The administrator creates it probably as part of a cluster, but the things that are really created on demand or by a user would be called the logical routers, called the T0 routers or a T1 router. Any questions on this slide? In terms of entry and exit, so on NSX-V, you basically identify a set of IPs that would be used as entry and exit points, uplink IPs, or denetted addresses. While with NSX-T, you don't have that option. There are no edges, so it's a little different. What you have is you need to use a border gateway protocol, BGP, or you need to use floating IPs and assign them to get routed via the T0 router. So the T0 router becomes your gateway. It's kind of static. It doesn't keep floating around. In terms of security groups, NSX-V is kind of tied to VMs. So you can say this VM can communicate with this VM, but not over here. With NSX-T, you can actually have much more fine-grained control with the security groups. You can say this app can talk to this app running on this container can be talking to this service. Or you can say a whole cluster of containers under this org can talk to this, but not this production or pre-prod database. So you actually have finer grain control, and this is what the system admins love to hear. And also you can identify that this particular call is coming from this particular app or a container. In terms of foundations, you can use a cookie cutter approach with NSX-V. So you can say, okay, Edge 1 would host the dev foundation, Edge 2, prod or pre-prod or whatever. With NSX-T, it becomes a little more harder because if you go the NATed route, probably it's a little harder to explain right now without going into the T0 router, T1 router architecture. In terms of OSPF support, there is no support in NSX-T. It does have support in NSX-V. PCF versions is like NSX-V is more of just at the BOSH level. There is no real integration within ERT. BOSH basically handles the VM. When it creates a VM, it associates a security group. That's about it. So PCF 1.x as well as PCF 2.0 would continue to work with NSX-V. With NSX-T, it is only in PCF 2.0 and forward. Because it's more, you are basically replacing the CNI engine in PCF with NSX. So it's not just security groups at the VM level, but you are also rewiring your brain to use NSX rather than the default batteries included Silk. How many of you know about the CNI Silk? Okay. Just after. And in terms of load balancer, you basically have a load balancer on the edge VM, while with NSX-T, it is kind of built into the hypervisor, so it stretches across the whole fabric. And it's supposed more scalable. So this is a high-level architecture of a NSX-T router. So at the topmost right corner, you see an edge cluster. So those are the cluster of edges you would pre-create either by the admin or by the infrastructure person. And then there would be like a T0 router that can be mapped to one edge instance. So the T0 router acts as a gateway for everything that comes in and out. And then you would create a T1 router depending on how you want it. You can have one T1 router having all the logical switches, or you can carve up multiple T1 routers for each logical switch. It's up to you. So these are logical. There are no real VMs involved. These are just logical concepts. So they handle the routing between things. And if they need to go out, they talk through the T0. And the LS1, LS2, those are logical switches. So you might have multiple VMs. They will be able to talk to each other. They will be able to talk across T1 routers. And the one on the right side, the lighter blue, those will be created dynamically for you as you start pushing apps, or you might, in Kubernetes land, you might be pushing new pods and namespaces. So those would be dynamically generated for you on the fly. They would have their own logical switches. They would have their own logical switch ports. So based on grouping, in PCF, the grouping is based on orgs. In Kubernetes, it would be based on the namespaces. So those would be created dynamically, and they would be hosting the containers. while on the left side it would be more around VMs. The ones on the right are more pertaining to containers. So NSX-T starts creating these T1 routers dynamically and starts assigning them to this particular router. So this is more of a network setup wherein you would have like a management plane that connects all the ESXi hosts, followed by an overlay with the transport overlay and transport layer. So there will be like a separate physical adapter or a VLAN, and then there will be external uplink. So the NSX Edge is the one that kind of talks to the T0 router and lets things go in and out, while others, the manager and the controller, kind of handle the control plane. And on top of the T0, there would be the T1 routers that have their logical switches. Any questions so far? Okay. So this would be the the final deployment model where you will have an Ops Manager that's 2.0. You would configure it with NSX-T, so you would see the leftmost side, you basically see that it is enabled with the NSX networking, and we select NSX-T, right? So the APIs are different between NSX-V and NSX-T. And then when you install the NSX-T tile, you configure the different options. Most of them are kind of straightforward default, but you will associate something called a foundation name that lets NSX-T identify which particular deployment, like a PCF or a Kubernetes, to associate with and start creating those T1 routers we saw earlier. And in between, with PCF, you will also go in and select under the networks applications, you would select external CNI provider rather than the default Silk. So this basically lets ERT switch from Silk to NSX. So the NSX tile you see on the rightmost side, it's an add-on tile. So it doesn't directly start running VMs directly. It defines a runtime config with an add-on wherein it says, I want to attach myself to the Diego cells and want to run the node agent for NSX. I want to attach to the Diego brain and run something called the NCP, the NSX control plugin. So the add-on tile basically doesn't create VMs, but it pushes certain metadata to BOSH director to say, I want to run along with certain other things. And when ERT comes and gets deployed, these two merge together transparently. So that way, like, ERT has the option to say, okay, I want to go with Silk, or I want to go with NSX or something else in the future. Any questions? Everyone knows about add-on runtime configs. So this is, I have been struggling to get add-on for a long time as a tile. Like, I worked with Dynatrace last year. We had been like, okay, guys, give us support for add-on. Finally, they are like, okay, for VMware, we can't say no. Okay, thank you. Okay, so this would be, in terms of PCF, how it would look. So you basically have a T0 router associated with the edge instance. You can have multiple T0 routers. Each can be only associated with a specific edge instance. And then you have T1 routers. You would have like an infra logical switch. You would have almost a similar reference model, but slightly different. You are not creating edge. You are creating T0 routers and T1 routers. And then the one on the rightmost, where the light blue, so those are kind of getting generated dynamically. And you can say, like, this would be the whole subnet, or you can give a very big, vast subnet, and then it will start allocating from it. NSXT will do the IPAM and say, okay, let me do with 1.0 for org1, 2.0 for org2. It keeps going up. So you can see, like, I don't know whether it's clear, 10.1.0.0, 10.2.0.0. So it keeps bumping up. So this basically lets NSX manage all apps on a given org at one kind of flat network, and then a different org, a different org. So that way it can actually apply policies a lot more easily. Any questions? You get to specify the sidebar for each of the org? No, you basically kind of specify the whole thing for all containers, and then it would kind of carve out a little piece for each org. Hopefully, like, you don't run out of it. You give like /16. So there should be more than enough, hopefully, before you run out of it. Yeah.
Dynamic services network, is that going to be on there?
So dynamic services would be ODB. So BOSH would basically say, like, okay, give me this network, I bring up a VM. But the right side is meant for containers, not for VMs, right? So that is done by NSX, NSX-T. It basically dynamically allocates IP for you and says, you are going to run. And here, apps can talk to apps directly. There's no more going around a Go router. And they are on a different plane. Just like, compared to ESXi host, your VMs are on a different logical network, right? So now your containers, even though they are running inside the VMs, they are on yet another logical network. It kind of reminds me of Inception, where some guy is in another guy's brain and then going through all those memories. It's almost like that. You think that this container is on the same hosted thing, but it is actually on a different logical plane.
The logical plane of the containers is different than the logical planes of the VMs.
Right. So earlier you would have seen like a NATed port for the CF app container. Here it's like straight direct. You kind of bypass the host. The Go router would directly talk to the container rather than going through the NATed address of the Diego cell to this one. And app to app would be straight.
How does the NSX Team Management talk to the container, the plugin in the container?
So there is a direct routing that is enabled on ERT. When it is NSX, we say allow direct routing. So the route emitters on Diego, when they normally publish the container address, they would advertise the NATed address. What would happen here is they would advertise a direct route. So the router would directly talk to this guy. So the routers are on this T1, while the apps are on a different T1. They would be able to talk to each other. This is a whole distributed logical router.
So the DLR instance will be there on every Diego cell, right?
What is that? DLR is kind of across the whole fabric. So you don't even have to worry about it. The routing is totally distributed.
So if one container is talking to another, and let's say both the containers are on the same Diego cell.
It doesn't matter. Forget about the Diego cell now. It's like I can talk to you irrespective of where you are through our phones. That's it.
Right. My question was more around if the two containers are on the same virtual machine, would the call be contained inside the network call?
It kind of goes over the hyperbus. It's along the ESXi plane. So there is no more like go through a VM. It's at the hyperbus level, which is on the lower fabric.
So the communication is going to be direct, but for network policy, it's going to
Yeah. Put the checkpoints.
You said that the router emits the direct address into the container. Can we leverage that to put policies outside? Does it affect firewalls outside the edge?
So, yes. So on the left-hand side, I don't know if it's too small, you would actually see like different logical switches created for each org. They don't get created unless you push an app for an org, and there was no app. This is the very first app for a given org. So then it creates a logical switch, and then there are logical ports. On the right-hand side, there are the different switches. For each app instance, there would be a logical switch port. Right now, Ops Manager 2.0 has support for add-on tiles. Hopefully, Ops Manager 1.x would also support it. So this would be the routing configuration. So you would, at the top level, you basically come in with a domain name for a system or application domain. You would have a load balancer from NSX-T that would basically look at the address and say, okay, let me send it to the specific server pool, which would host the Go routers. So that would be taken care of. So 140, like if you look at are people able to read the values IPs from the back? So the 10.193.105.140 is mapped to Go router in the DNS servers, and that gets denatted into the 192.168.20.30 address on the inside. Actually, in this case, since we go through the server session pools, there is no denatting. The load balancer basically drops it onto the server session pool. The server pools basically transmit back to the Go routers. On the left-hand side, Ops Manager doesn't really need a load balancer. You would do a direct DNAT. So from 130, it becomes 192.168.10.30. So that basically goes to the Ops Manager. You would set NAT and DNAT rules, SNAT and DNAT rules at the T0 router level. So you can actually set NAT rules either at the T1 router or the T0 router. Setting it on the T0 router basically says, okay, everything can go out NATed only when they cross the threshold. With T1, you don't really want, particularly like we are kind of creating dynamically the T1 routers, so we don't want NATing to happen when app is talking to another app or a VM is talking to another app. We don't want that. So we set the NAT at the T0 level. So you can see the BOSH director and the ops manager is on an infra logical switch. ERT would be running with the Go router or a HA proxy. There can be services, and then like for each org, there would be a different, distinct T1 router getting created. So those would be like the DNAT and SNAT rules you set up on the T0 router. And these would be the load balancer configurations for coming into the Go router. Any questions? So in terms of, yep.
So if you have a route service configured on an app, which other app is just internally trying to talk to, the route service won't get triggered there, right? Since the route
So the route service is handled by the Go router.
So if you have bypassing Go router is not coming into the picture.
Yeah, there won't be any route service, app to app. So in terms of app security, there are two ways of controlling what apps can do. So one would be the ASG, the application security groups, that basically applies a egress policy. So when you try to talk outside to a endpoint or a service or any other public or whatever private address, ASGs kick in. So those are supported with NSXT. The same way you also have container to container app policy you can apply through the CF command line. CF allow access A to B on these ports, on these protocols. So those are also applied with NSXT. So you would actually see these different firewalls and security policies on the NSXT side. So the administrators can actually come in and fine tune it or say, okay, I'm going to let you go for this one, I'm going to lock you down. I don't like this one. I want to kind of tamp you down or whatever. So this basically lets you identify which apps are talking where. And also the other side is, because each app gets a distinct IP, you can actually say, who is talking to my SQL database, or who is talking outside to this particular service. Earlier it used to be that, the NATed Diego cell host address. You're like, okay, there might be 250 apps. You don't know which one it is. Now here you have a distinct way to identify who is doing what. So that is where the micro-segmentation applies beautifully over here. Any questions? Okay, demo? No demo? You guys want to take a break? So, I'm going to, first, before doing anything, let me quickly show you. Hopefully I have not got kicked off. So this is the NSX Team Manager dashboard. Probably you never had to worry about it with NSX-V. Everything happens on the NSX-T over here. So you have got the basic routing. So this is the default T0 router on which everything happens. So there are router ports basically for every T1 router we create. I created two T1 routers, one for the PaaS, one for the infra. So this management is basically for the infra, the BOSH director and ops manager, then the remaining for PaaS. So these are the other T1 routers that got created for each org that we were testing and creating. So you would define a static route to say like, okay, how do I go out for the T0 router? So you basically specify the gateway for the T0 router. And here you basically specify the NAT rules. I wish there's a little, how do I, oh man, okay. What can I do? Okay, so we have to live with it. So you can specify the DNAT and the SNAT rules to say like, what you want to expose outside, what needs to come in, how things should go out, should appear on the outside. So you can say this particular org should be getting mapped to this particular IP. So that way people can say, okay, all these requests are coming from this org. So let's drill down into who is running all these flaky things or whatever. In terms of switching, so switching is where you specify the logical switches. So I created the top 4. The infra for ops manager and director the ERT, the dynamic services, then they would be associated with a specific T1 router. So these are all the different T1, the logical switches that get created as part of the OR creation and apps. So you can look at the ports. So if it is CATS1, there is just one logical port. Container ports. There are no container. So let's go back here. So let's create a new org. So there is a total 20 right now. So we are still at the 20, so let me refresh. So I'm going to push an app, Dora, as Dora SpringOne. So it's starting to create the container. Hopefully the gods of demo are happy with me. Successfully created. So let's start. Do we see a 21 now from 20? So we have got a new logical switch that's associated with the logical port. So that's an app, CF Dora SpringOne. So let's go back to the switches. So let's refresh it. We have one app. It's kind of going away. So it kind of starting again. So let's try to access this one. Dora Spring, hi, I'm Dora. So I'm going to scale to 3. Let me just go back here first. So we are seeing just one instance of Dora. You guys see it? And in terms of firewall, you can basically see all the different settings. So these would be the ASGs that get created as part of like a public networks or a DNS network or whatever is default built into CF. So we can, so SpringOne. So there is a ASG for the SpringOne, like a top one. So it's like allow all. And then we can start adding things and we can, have people seen the front end and back end, the cats and dogs sample for CNI? You want to see or you don't care? Want to see? This is all using NSX. No, NSX is kind of becoming the brain for the CNI implementation. It's like, okay, it's like you are driving the gasoline engine. Now you are switching with the EV, with the electric engine. That's the thing. You're swapping the engine under the thing, hood. So people want to look at the Ops Manager? Or, okay, let me first push this one while. So this would be the Ops Manager. So normally it would be just Silk. So these are the configurations I was talking to you about. So this is where you basically say, I want to use NSX networking with NSX-T. That's on the Bosch director configuration.
So once it is deployed, if I want to, right now if I just delete the NSX style, we fall back to using the
Silk. But you need to also change the option on the pass style. Pivotal Application Service, which is previously ERT. So prepare to be confused or tripped on the different, so this is where you basically say silk versus external. So this would be the approach if something else comes along and we have a different CNI provider. Okay? So now this is up, let's access this. So this is my overlay IP address, which is not really anything to do with the logical switches. You can see this is a totally different subnet. So now we are going to push the front end, SpringOne. So was this session useful? So. Hopefully I didn't sell a bag of tricks. Okay, so I know it's like quite late for most of you. With the NSX-V, you can actually, Bosch kind of creates a dummy, empty security group. Then you can say like, okay, this one can talk to this one, but you don't really know the app container IPs. So you're like, from Diego cell, it cannot talk to this one, while it can talk to this one. That's about it. It's very coarse, while this one is like really fine-grained, you can lock things down.
So without using NSXT in ERT config, I remember there is an option where you can specify like 10 or something, right? So that's
Sure, that's a CIDR, yeah, for the apps. So this one, you can actually specify what CIDR to use. So in, yeah, right. So here. So this is my container IP pool, which is 10 to 1010. So from there, it starts carving things out. Okay, so now we have got front end. So we want basically the front end to talk to the back end. So this is bypassing the Go router. This is basically saying, given that I have my address, I want to directly talk. So this is 7007, yes. So now it's trying to connect, and it's like, I have no idea what you're talking about because I cannot talk to this guy, whatever you said. So now I'm going to, okay. So I need to, will I be lucky this time? Let's see. Okay. Awesome. The cat is like, some say I'm also like that when I'm furiously typing on a conference calls. Okay.
So CF allow access effectively a policy in NSX?
Yes. So that's a policy server on CF that is used by NSX to say, okay, what policies should I apply for these apps? So earlier we kind of saw like there was just one and SpringOne. So let's refresh. Where is my refresh? So backend. So it basically says, allow things to come into backend from these particular logical ports. So that gets created by NSX by polling for data from the policy server on ERT or like PAS.
Can we specify that in the apps manager or something? Like, this app can talk to this app.
They are planning to add that capability a little later, yeah.
So let's say I deploy an app, gets an IP address in the container. Now if it
Nope.
Let's say I delete it and then I deploy the new app,
Yeah.
and then I go back and deploy the same app, then I have to go back and change the policy.
It's up to you. If you come back with the same app ID, app GUID, or identity, then those policies might stay. But if you clear it out completely, then you're kind of starting from scratch. And also, this is meant for more greenfield deployments. It cannot handle like existing PCF, move it around and let me get it running. Because this one has to know like, what are the apps, what are the orgs, what are the spaces I am going to control. So anything that was created previously, so let's say you went with Silk, you deployed the thing, and now you come back and say, let me switch to NSX. It won't have any idea about the orgs that were created previously, like a system org or something else you created. It would only know exactly what you tell it to manage from that point onwards.
How do you secure like traffic from an outside app outside PCF? Set some policies.
You can actually, in the firewall rules, it's a distributed firewall rule, you can set whatever you want. You can say this org should be logged out, should not be allowed from outside. So it kind of carves out the whole, it basically has a CIDR, right? It basically has a subnet. You can say this org cannot be exposed out, or like just reject plainly. Okay? Any other questions? Was it useful? Thank you.